Okay, so let's try another one of these rearranging things where there's duplication. So suppose we have the word bookkeeper, which is a nice word to know because it has lots of double things in it. Okay, so how many letters are there total? Like, how many slots am I going to be filling by rearranging bookkeeper? 10? 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. Okay, so I think my options are going to start with a 10 factorial, right? And then I need to slice off some of these. You with me? Oh.
Yes. Now I got it.
Got to do 11. Bookkeeper doesn't
No.
go to 11. It's a bookkeeper. Okay, it wasn't a pun. Give me a break.
I didn't notice.
You're too young. All right, so I have 10 slots to fill, right? So I start with 10 factorial. Then why am I slicing stuff up?
Because it was two.
Yeah, because apparently this, right, would be a rearrangement of bookkeeper, but it doesn't really look like it, right? Because I didn't mark the O's. You guys see that? If one of them had a little accento or an umlaut or something on it, that would be a really bizarre word. And also it would start to matter, right? So how many repetitions are there for the O's? How many, what do I have to slice out for O's?
2.
Yeah, there's 2 factorial, right? 2 factorial is really just 2. You guys see that? So I'd slice out those 2 rearrangements. How many rearrangements are there in K's?
2.
Also 2. So I should also slice out the K's. Then how many rearrangements are there for E's?
3.
3. So I need to slice out a 3 factorial to get rid of the rearrangements of the E's. You guys see this? Does that make better sense?
No matter how you ultimately end up rearranging it out of a 10 factorial, you could switch the O's around. You wouldn't be able to tell the difference.
Yeah, exactly. You guys see that? So think about the top as, hey, we're going to rearrange this one where I marked the O's, the K's, and the E's different. And then I'm going to think to myself, well, swapping O1 for O2 shouldn't make any difference at all. So I want to slice out the number of ways there are to swap O's around, the number of ways there are to swap K's around, and the number of ways there are to swap E's around. Does that make better sense? Cool.
That's what's confusing the L1, because there's only 2 of the same.
But there's 3 different options for which one's the same.
Yeah.
This is better because I know which ones are the same, right? The O's can switch. So there isn't that, like, I don't have to introduce some other factor to deal with the O's.
How come we can't just do it like count the double letters as like 1? So you know what I mean? So can we just like 10 over 6 instead of all this?
Yeah, so that's a fair point. So why aren't I counting the double letters as kind of one object?
There's another E in there.
Yeah, for one thing, there's another E, and they don't have to stay together, right? If I said, how many options are there to rearrange bookkeeper and keep the O's together, then yeah, treat them as one object. We'll do that sometimes when we're talking about people. If we're rearranging people, and Hope and Megan have to sit together because, I don't know, because they said so, right? Like, especially this happens at weddings where you have to see couples together for some reason. Right, when you're trying to arrange people, you might have to account for those 2 people as one object, but then maybe there's another arrangement like, oh, well, the guy could sit on the left and the girl on the right, or vice versa. In this case, right, that wouldn't make any difference because they're O's and you can't tell them apart. You guys cool with that?
Wait, so that's the
Okay.
That's it?
Yes, this is the answer for the bookkeeper thing. That's how many rearrangements there are. This is not like traditionally a number, right? Okay, so fine. You guys want some practice, we'll get a real number out of this. So, what does the 10 on top mean? Okay, it's 10 factorial, so it really means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, what does all that crap on the bottom mean? There's 2 times a 2 times a 3 times a 2, and I stopped writing ones because I got bored. You guys all see that? Okay, so I can do some canceling, right?
Yes.
Onesies. So we can onesie some 2s
And some 4s.
and some 3s and that 4 and that 4 there. And so all told, I could reduce this to 10 factorial over 4 factorial.
Why is the first one there if you cancel it out?
Because because it's on the bottom.
I understand that it's on the bottom. But you cross
I just rewrote factorial land.
2 factorial,
Right,
2
so
factorial, 3
just-
factorial make 4 factorial.
As a usual number, this is 10 times 9 times 8 times 7 times 6 times 5. Which is like a lot.
Yeah.
Somebody want to give me an actual number for this? And then I'll explain where the 4 went.
It is
Yeah.
151,200.
Okay. So this is 151,000 rearrangements of the word bookkeeper. Great. Cool. Neat.
That's how we get those puzzles.
Good question. How many of them are actually words? Yeah, that probably takes time.
That's a dictionary attack.
Not a lot. Yeah.
Or
the-
some computer program that
So-
generates all 151,000.
So I recommend that you write a computer program to generate all the words and then check them against the dictionary.
Oh yeah, just go do that.
Because you don't want to do this, right? Like you personally should never think about doing this. The reason I want you guys to have some facility with this is just so you can ballpark, like how big a deal is that, right? So if you tell a computer to do this process, right, go write all 151,000 words, check them against the dictionary, how long is that going to take?
The computer?
Yeah, how long is that going to take, say, a laptop sitting in this room, right?
Laptop generally
It's
runs
2016.
about 2.1 gigahertz, which is, yeah, so to generate those words, we're going to...
My guess would be that this would take on the order, and I mean within a factor of 10, of an hour. So I think this will take someplace between 6 minutes and 10 hours.
Also depends on the language you write it in.
Yeah, and it depends on how efficient you are. If you don't teach it to check dictionaries with dictionary ordering, but instead you teach it to check dictionaries by comparing it against all the words, it's going to take a really long time. So there's some computer efficiency here,
Yeah.
right? But what I really want you guys to think is, okay, this is a reasonable task to accomplish. Like a computer can do this. Versus something like rearrange all of the words I've written on the board today and see if a coherent lecture could be made using those words in a different order. You guys see that? Like, that's a bigger project. Does that kind of make sense? Okay. So, some of these machine things, it's nice for you guys to have a, like, 150,000 things is not so unaccomplishable. 10 to the 30th things is not going to happen in finite time. Let's go up. or at least it'll happen in finite time, but not while I'm still breathing, kind of thing. Cool. Do you want to know where the 4 came from?
Yes.
If you write this out,
The 4. Write the 4 out?
write the factorials out.
Okay.
So this is 10 factorial, right? It's all this stuff.
Yes.
And this is 4 times 3 times 2.
Okay, well, why did you write that again? I'm so confused with what's going on here.
Because I noticed it still had like 6 things, and so I wrote it the short way. I'm just screwing with your mind. I just want you to get some practice playing with these. So there's 2 ways, right?
Okay.
You write it out the long way, you cancel, you end up with something long still, right?
Yes.
If it's still in order, you can rewrite it as a factorial that's maybe a little shorter. See how my factorial got shorter? So in one thing, I condensed in factorial land. In the other thing, I made it into a regular number.
Okay, so 2 factorial and 2 factorial times 3 factorial is the same as 4 factorial, but that's not the 24. And that's why I put 4 factorial, because it's the same thing.
Yeah, this whole business
But it looks nicer.
is 2 times 2 times 3 times 2,
Yes.
right? Which is
24.
4 times 3 times 2,
Mm-hmm.
which is 4 factorial, which is why I wrote that. Crazy, right?
Yeah.
So the factorial thing is really about shorthand.
Okay.
Right, and so I just want you to develop some okay, maybe shorthand is better here.
I
Cool?
have a question.
Yeah.
How come, so when you write it out, how come it's not like 2 times 1 times 2 times 1 times 3 times?
Sure.
How come the bottom one isn't?
They're all multiplication by 1, right? So they don't change anything. So I just left them
Oh,
off.
okay. Got it.
Yeah, I said that really fast as I was writing it. I was like, and I'm tired of writing, so I'm not writing ones.
Okay.
Is all good with this?